Welcome everyone. Hope you can all hear us well. Uh, and I hope everybody's been enjoying KubeCon. It's been a crazy week again. We'd love to hear what you enjoyed most of this KubeCon. Please share that in the chat with us. It's the final day and the final deep dive of the week. And I'm joined here today by Ashwin, an engineer on the Consul team. Do you maybe want to introduce yourself?
Sure. Happy Friday, everybody. Welcome to the last day of KubeCon. I'm Ashwin. I am an engineer on the Consul and Kubernetes team here at HashiCorp. And yeah, for the last year or so, I've been working on building interesting things on Kubernetes for Consul. So happy to be here. And I hope we all have had a good day so far.
Yeah, I'm excited to show some of the things that you and your team have been working on. Could you maybe talk us through some of the things that have happened since last KubeCon, which is it feels like years ago, but I think it's 6 months.
Feels like forever.
Yes.
Last KubeCon. Yeah, so we've had some interesting developments that we've had on Consul. So a couple of things that we've been working on since then is, I think we introduced CRDs sometime around last KubeCon, but we've been working on kind of fleshing them out some more. So that all of your config entries are now custom resources, so that it's Kubernetes-y. Outside of that, we've been working on doing some like native integration with metrics, so that it's very easy for you to get Consul metrics both on the Consul UI, but make it really straightforward to like plug and play with Prometheus. Where at this point of time, we do have a demo installation of Prometheus set up, such that when you install your Helm chart, you can kind of toggle a value on. They should install Prometheus for you on your cluster, and then also configure it such that your Consul server metrics, your app metrics all start getting exported to this Prometheus. Additionally, like an interesting thing that we've done there, which I thought like was really cool, was this concept of metrics merging. So that if you have an app that also kind of generates Prometheus metrics and you have the proxy running next to it, you can configure it such that we kind of have a single endpoint on that pod through which you can scrape both your app metrics as well as your proxy metrics, which makes like previously you'd kind of need to configure a separate endpoint on Prometheus for the proxy or for the app, because at this point of time, it can scrape just the one endpoint. We made it so that it should be easy to just get it from a single place.
So does it also add like common tags on those metrics then automatically as well? So they're grouped
yeah, for the most part, like really the metrics as it is generated by Envoy should be tagged by Envoy itself. But additionally, yeah, you should have all of those tags required, which should make it very easy for you to kind of go through all of those metrics that Prometheus has in store and find the ones that you're looking for.
Yeah, so I can more easily find, oh, this is from my application, this is from the sidecar that belongs to it.
Exactly.
That's really, really useful.
So that, yeah, exactly. And I'm looking forward to like people using it and playing around with it. And hopefully it makes people's lives easier.
Yeah.
And this last thing that we've been working on that I think is really, really great is adding transparent proxy support into Consul now. So in the next release of Consul, which is 1.10, which is like around the corner, we should have transparent proxy, which should make it, again, like it's one of those fun things which allows users to configure their apps to talk to each other as if there is no proxy in the first place. That is something that I think it feels like a game changer and should be really valuable for people.
Yeah. So before we show off this cool new feature, just a question about the first thing you were talking about, right? Like CRDs, maybe for people that aren't very familiar with it, like what does that change for people using Consul on Kubernetes compared to what it was before?
That makes sense. That's a great question. So, well, for those of you who are familiar with Consul, all this while when you wanted to configure your service mesh, you kind of use these config entries. So these were config entries for service defaults, proxy defaults. There were those to configure your gateway. So you had different ones for your ingress gateway, for your terminating gateway. There were config entries that allowed you to do L7, like set up L7. So this was intentions, but some of the other things were service routers, service splitters, and service resolvers. So all of this so far was like you'd create HCL for them or JSON for them, give them to your Consul CLI and kind of do a Consul config entry create. Now, this was like well and good and super useful, but we found that there were occasions where there were people who like were familiar with Kubernetes who wanted to use these more as resources on their cluster that they could like kubectl get and kubectl edit and kubectl apply. And for them, we created these custom resources. So you have a controller that you deploy, and you can create these Kubernetes resources similar to your pods and what have you, but you can create those specific to config entries for Consul. So we have a separate like custom resource for each of these config entries that I've mentioned, like for your service defaults, for your proxy defaults, for intentions. And this makes it fairly straightforward to kind of know like, hey, here's my cluster. These are all of the config entries that I have applied. It makes it much easier to manage it from like, you have a single source of truth, which you can access using your Kubernetes CLI.
Yeah, and it's nice and declarative as well, right? It's like, hey, exactly. The configuration that I see there, that is what's applied. It's not a series of commands that have been run.
Exactly. And hopefully like when things go wrong, you can kind of look at the logs of the controller. It should give you more information as to why something got applied or not. We try to build in like really smart validation behavior and defaulting behavior, where if there is a config entry that cannot get applied, say because you typoed a thing or you forgot a field that was like necessary,
or some indentation errors in your YAML.
That one. Well, those ones are the most fun ones with YAML, aren't they? But yeah, if you have some of these issues, hopefully the controller should be able to like reject it, but also give you a valuable error message saying, hey, you set a field and you said HTTP, but the values that we accept are HTTP and TCP and the likes. Yeah. So hopefully that should make it less error prone, make it easier for you to do the right thing from the get-go, and also allows smart things like kubectl edit, where you can update that config entry and you know that in the back, like it automatically updates Consul with your updated resource. So it's a good way of just keeping, it's like you said, it's declarative, and we're trying to take advantage of the declarative engine that is Kubernetes and kind of ensure that all of your config is in one place and all of it is up to date Consul at all points of time.
Yeah, like for me, I often run Consul on top of Kubernetes. Mm-hmm. It's a really nice way to interact with the configuration.
Right. So, I mean, like I said, Erik, you use it. How have you found using CRDs in your day-to-day? Like from moving away from using config entries the old way to starting to use CRDs, how has it impacted your life?
So for me,
Mm-hmm.
it's been way nicer, because normally I had to think of more of like a life cycle where it's like, okay, I have the configuration for my proxy defaults and resolvers and all those things. I need to make sure that, have I applied all of them? Have I run all the commands, right? And then make sure that they're all correct and that they're correctly applied. Now with CRDs, I just define it with my services and my deployments, and it just automatically gets deployed. I can beforehand lint it and make sure everything's right. And I know
that's true. It's all in one place. Exactly. Like all of your configuration can lie right next to whatever your workloads are. Yeah. So it's very easy to introspect into like, here's my workload, here's my configuration for that workload.
Yeah. And you were mentioning the controller, that you need to run one. But that's part of the Helm chart as well, right? Like people don't have to worry about having to run their own controller.
Oh no, this comes along with the Helm chart. So part of the Helm installation here on out. So at this point in time, it still defaults to being false out of the box. But if you want, you can enable the controller. So I think the key is called controller, under which you have a field enabled. But if you enable your controller, it should spin that controller up and will also, so when you enable the controller, it spins up the controller and also installs the CRDs onto your cluster.
Okay, nice.
So these are the two things, that happen when you enable the controller, and there on out you get all of that goodness of declarative config.
Yeah. All right. So I think that was the other big thing, CRDs, right? But the one I really want to talk about today is transparent proxies. And so there's a demo, and I believe I have to basically drive the demo for you while you
It's that
instruct me
easy,
through
Eric. It's that easy. That's why we're doing it this way. It's like it's fairly straightforward. I mean, I guess that to give people an idea of what the proxy is. So previously, when you were configuring your apps with Consul and you're deploying services to Consul, if you wanted to set up, like mention that service B is upstream of service A, you needed to annotate service B with an annotation, which was Consul specific, that says, hey, here is my upstream. The name of my upstream is A. You can find, and you should reach out to A on this port. And I mean, it is fairly straightforward, but so, ideally what we want.
Ashwin, do we maybe want to show them while you
let's
talk through it?
Let's do it.
Since I'm driving your demo, but I still would like you to have like a little webcam thingy. Do you mind sharing your screen, just anything blank, and then I'll just overlay my part of the code? So then it'll actually look like you're running your own demo.
Oh, perfect. Let me share a blank screen, but that is going to be my terminal so that it just feels aesthetically correct. All right.
So now, there we go. You suddenly switched from Mac to Windows. Congratulations.
Thank you. I was looking forward to this day.
So you were saying, right, normally we would configure our Kubernetes deployments with annotations, right?
Exactly.
So I have two services here. We have web and API, and then web talks to API, right? And I think what you were talking about are these annotations.
Exactly. So this specifically the second annotation, which is connect service upstream, where you had to explicitly mention like what the upstream was.
Yeah.
And in situations where you had ACLs enabled, you also needed to create a service intention. So it almost felt like it was a duplication of effort to a certain degree, where not only would you have to tell the app explicitly what its upstream was, you then had to go into and through wire config say that also allow it to talk to its upstream.
Yeah, and you had to also specify the port that it would be exposed on locally, right?
Exactly. You'd have to expose that port so that it could wire itself up correctly.
Yeah.
And this was so that you could. So the purpose of this was to register that upstream with your local running Envoy proxy. So it would register that API as an upstream for the proxy running alongside web.
Yeah.
Now, what enabling transparent proxy has allowed us to do is kind of circumvent that, or more specifically, allow it to almost transparently be aware of the fact that, hey, there is this, like, the API is aware that there's a web, and web is aware that there's an API. And because each of them, if you like the update, what's different now is that every single deployment needs a service alongside it. So you need to deploy a service with your deployment. But the advantage of having this service is it kind of lets the proxy know that, hey, there is this service, and hence you know that there is a destination that you can go to because a service exists.
Yep.
And what happens now is immediately the proxy that's running alongside web, API gets registered as an upstream for it. This isn't the case, like the upstream gets registered if you don't have ACLs enabled. When you have ACLs enabled, as soon as you set up an intention saying allow web to talk to API, the proxy for web gets updated with an upstream for API. But all of this happens like behind the scenes, under the hood. As far as I am concerned as a user, I just say, here's my deployment for web, here's my deployment for API, here are the services for the two of them. Like, apply this configuration onto Kubernetes and things should just work.
That's really neat. So I didn't know this yet about the intentions, right? Because normally it is like, hey, you would have the upstreams, that the listeners would still be there, but in the communication part, it would fail, right?
Exactly.
But it's nice that now, when there's no intention, the entire listener is not there.
Exactly. It's just not configured. It's as soon as you create the first intention that, as and when you go about creating your intentions, you have your upstream config updated with, hey, here are all the other services that I am allowed to talk to, and now they're registered as in my proxy.
Okay, so we showed the before, right, where I have in my web deployment here, I enable connect, right, so that I get a sidecar injected. That's still the case in the new situation as well, right? Like, unless you basically set it to be enabled by default for everything, but
exactly, that is still the case. So this allows you to, if you just want to deploy a service and you don't want it in your service mesh, it's just a workload running on Kubernetes, you have the option of not having it deployed in your service mesh. So you still have that annotation that gives you that handle over it.
Yep.
If you want to be in a situation where you just want everything to get injected, you can update your Helm chart to say just default to like injecting everything that you have into the mesh, and it would do that for you. And in that case, you wouldn't even need this annotation. So it would just be a regular deployment that you apply, and it's in the mesh.
So the other big thing I noticed is we had this before, and you were saying like that's no longer needed anymore, right? Where I specify I want to reach this servers on that port.
Exactly.
So it's missing here, right?
Yeah.
And you were saying that now it actually works through services, and by that you just mean Kubernetes services, right?
Oh yeah,
because we were getting this question, like, perfectly timed, Brian, thank you, in the chat as well, right? Are these services Kubernetes services or Consul services? So they are Kubernetes services.
Yeah, these are Kubernetes services, right? So with every single deployment, like
just like you would do on vanilla Kubernetes, you would create a service for your pods, as we have done here for API on port 9090. And then the big difference then is calling your upstream, right? Because normally before I would reach out to localhost 9091, for instance, right? What do we do now?
So if you want to configure your upstream, so having this service and having an intention for it configures your upstream. And if you want to expose it, like say you want to hit, in fact, instead of hitting localhost 9091, you'd hit HTTP, like you'd hit the HTTP, the DNS, kube DNS address of the service.
So basically the default, like just the name of the service, right?
Exactly.
If it's in the same namespace.
Precisely. It's whatever kube DNS gives you, you can use that name and it routes to it.
Yeah. So in this case, I've pointed it at HTTP, API, port 9090, since that is what I have defined here. And that is basically everything you need to do, and then the rest works magically behind it. We had a question in chat. How does this work with the MTLS then in the new situation?
In MTLS. So with MTLS, at least you'll still have MTLS because your proxies are going to talk to each other over MTLS. What we're doing behind the scenes is like noticing the fact that, oh, you got a service. Here is the DNS address of the service that is deployed. Here are the services that it maps to. And then kind of letting Envoy, we set up our own DNS to look like kubedns with all of these services. So you still get all of the goodness of, well, Envoy proxy, which is MTLS communication between each other.
Okay.
But it just appears to be like regular kubedns where behind the scenes. So we're giving you all of the security with the simplicity of it just looking like good old-fashioned kubedns.
Yeah. So for people coming from just vanilla Kubernetes, it'll feel exactly the same. They're basically only adding one annotation. If they configure it globally, not even that, right?
Yeah,
they would just create their deployment. A sidecar would get injected. They would have MTLS going between everything, and they would have intentions to be able to gate traffic.
Exactly. Then you can use, again, exactly what you said. You can use intentions to gate traffic, to configure what gets to talk to what, and you ensure that all communication is over MTLS. and it's that simple, I guess.
Yeah, and so we have this actually running, right? So we have this configuration. Let me just pop up this and make that a bit more clear. So let me scale this to match Ashwin's screen size again. We were running into a few issues with the demo where it wouldn't work on Ashwin's machine. The funny thing is he built it on his machine, but it didn't work on his machine. So it's the opposite thing of containers, really.
Indeed, it'll be fine. It's a it's a demo. Things don't go wrong with demos.
No, exactly. So what we have in our demo, let's see if I can zoom in a little bit to make that a bit bigger, is we have two Kubernetes clusters in basically to show the things side by side. There we have Consul installed through the Helm chart, and I'll highlight the little differences between the Consul values files, but I was surprised how little configuration there is there as well. And then we have our applications just running with that Kubernetes YAML file that we just showed. Now, if we head over to, I have this open as well. Let's see how that frames up with Ashwin's screen. Now everything's at least resized to his monitor. We can see that we have in the first one on 18500, we have the non-transparent proxy setup, right? And what surprised me is that from a user perspective, I don't see any difference here as well. So I don't see that it is using the transparent proxy, because I'm switching now between the tabs and it's like literally the same. So is there no tell that I'm using the transparent proxy from the UI?
I think there is a tell. There is going to be a UI refresh that comes out as well with it.
Okay.
And with that UI refresh, it will definitely indicate like, hey, these are your apps. They can talk to each other at transparent proxy. Like it'll tell you for each app what its upstreams are.
Yeah.
And it'll be like it will let you know like via transparent proxy who can talk to, like which apps can talk to which other apps.
Okay. And will that be kind of like we see in the routing where you see the lines going from one to the other to show how it's actually lined up and stuff, or?
Yep.
Okay, that's really cool. Now, the big test, of course, is to actually run the applications and see that we actually do get this. So let me make it easier by just using the actual UI, right? So we see that web can reach API on localhost 9091 in the original setup, right? That was very simple.
That's right, yeah.
Now, the cool thing I find as well is that now the upstreams are more clearly defined as well, right? It's more clear what you're actually talking to, since I can now actually clearly see that I'm trying to reach the API instead of just localhost, localhost, localhost.
Exactly. It's like you don't have localhost anymore. You don't have to do that inference. It just, it's hitting the API. It just, you tell it where you want it to go.
Yeah. Yeah, and Brian is saying like this is a lot simpler. He's currently generating all of the Kubernetes configs for all of these steps. And the upstreams is for him usually the most redundant piece and the hardest piece to configure dynamically. So
Brian, I hope you like this. I mean, 110 is around the corner. It should be out, I'm hoping, in about a couple of weeks, maybe a little more. But I'd love for you to play around with transparent proxy. Hopefully, you won't have to configure your upstreams anymore. Like you just need intentions and that's it. It should just work.
Yeah. Now, if anybody has questions in chat, please throw them in there, and we love to show you whatever little nook and cranny you want to see.
If you have any questions, like feel free to use this time to ask us those questions.
Yeah. So one of the things I wanted to to still show is the actual configuration of the Helm chart, right? So
yeah, that's a good place to look.
So without the transparent proxies, I have that controller enabled, like you were saying before, to get the CRDs, right? But other than that, like the transparent proxy here is disabled, and
so
go ahead.
So what I was getting at, I think we've got interesting modes. So with transparent proxy, default enable just says, hey, it's enabled for all the namespaces that you want to have your service mesh running on. Like here are services in these namespaces, just anything that's in this namespace, try and like put them into the mesh if they have the right annotation. So default enable just says whether on a global level it's activated or deactivated. A user can still explicitly go like into a namespace, update the config of the namespace itself, like the Kubernetes namespace, and say, hey, I know that it's deactivated on a global level, but any services that are on this namespace, like use transparent proxy for them.
Okay, wow, that's really cool.
Yeah, and you can still explicitly on the app itself say, hey, I want to use transparent proxy on this app. So we are allowing.
How would I do that? Is that through an annotation or?
That's through an annotation.
Okay.
So you have an annotation that you can put on the app itself.
Yeah.
That is a label that you can stick onto the namespace, and you have this global config. So using these three, we're trying to give users a little more fine-grained control into where you do use tproxy if you'd like to, tproxy being short for transparent proxy, and where do you not, so that you have a lot more knobs that you can play with.
Yeah. No, like I especially like that it also allows you to like step by step move towards using it, right? Like let's say I come from entirely vanilla Kubernetes.
Yeah.
I might just want to try it out in one namespace first, right? And do everything there. Or if I'm already using the older Consul setup, right, with the upstreams defined in the annotations, I could do it per application where I'm saying like, okay, yeah, we tested this with the new setup. We have a service deployed in Kubernetes. We can switch this app and then go app by app.
And you can precisely, it allows for a migration of your workloads so that you don't have to worry about all of your workloads suddenly needing to get updated. You can take it one workload at a time, where you can start migrating a workload to use tproxy. And as you get your hands around, like get comfortable with it, you can start moving all of it to start using transparent proxy.
That's really cool. So with the configuration of the namespace, how would that work? Is that a CRD that I would deploy to a namespace, or?
You could, so ideally what you do is when you have this, similar to how you create services, one can create namespaces, right? Yes, you have like kubeyaml that says, create a namespace for this. So when you're defining a namespace, what you'd want to do is add a label to that namespace. And well, I don't remember the name of the key off the top of my head. It's consul.hashicorp.com / transparent proxy enable, something in those lines.
Yeah.
And then you can set it to true or false.
Okay.
And when you apply that, it'll create a namespace, or you can update an existing namespace with a label. But as soon as you do that namespace or our controller will specifically look only at that namespace or it'll look at, hey, this pod is in this namespace where tproxy is enabled. So I am going to try and I'm going to set it up with transparent proxy.
That's really nice, because I thought it would be like a separate CRD, but having it basically on the native Kubernetes resource, that's even nicer as an annotation.
Like we're trying to go like as bare bones, use what Kubernetes gives us as possible here. And that's what we've been trying. Like this entire exercise for transparent proxy has been to try and kind of empower people to use existing Kubernetes resources that Kubernetes gives you. So it looks like you're using vanilla Kubernetes, but you get all the benefits of using a service mesh while still getting a user experience, I suppose, that is similar to vanilla Kubernetes.
Yeah, no, I think that's really awesome because there's already so many components that people have to learn, and there's new tools and features every week. So being able to leverage some of the things you already know with these new tools and features is amazing.
Right. And that's what I like about this one particularly, is because it just allows you to go from not having a service mesh to having a service mesh where all your workloads are running. And it's almost like you didn't have to do much other than installing Consul. Everything else just was, now just reapply your workloads, and all of your workloads are now running in a service mesh.
Yeah, so if I'm transitioning, right? Like obviously if I'm going from vanilla, I add the annotation to my deployment, it'll automatically update and it's now using it. I guess the same would apply for if I'm running the old version, I remove the upstream annotation and it should pick it up automatically.
I think at this point in time, we wanted to ensure that existing workloads are not disrupted. So if you do want to move like an existing workload into, like, you want it to run with proxy, you'll probably want to re-inject it. So you want to reapply that workload.
Okay, so destroy it first and then
reapply it. This way, it's mostly so that the user has control over when this happens, and there isn't disruption in where they weren't expecting disruption.
Yeah, I get that, because obviously it's multiple applications linking together and they could be dependent on each other. If one starts talking through the transparent proxy, that might not
things could behave in ways that are unpredictable, and that's probably like the worst scenario, and it's a situation you wouldn't want to find yourself in. People want predictability, and like, hey, you're ready to move your workloads to use the proxy, like delete the old one, reapply it, it'll get picked up by like the webhook that we have. It's gonna provision it with the correct init containers and the correct runtime containers to have your proxy sidecar and register itself, and things should just work smoothly there on out.
Yeah, I was also just thinking that the mechanism of enabling it for a namespace might also be a nice way where you create a new namespace with it enabled, and you move a duplicate of the application to there, see how everything behaves. If that's fine, you can basically move it then from that namespace back to...
Exactly. It gives you like a sandbox namespace, I suppose, where you can run all of these things, validate that it works the way you expect it to. And once you validate it in your sandbox namespace, you can reissue the workload onto the namespace that you wanted to run it on, and things should work as expected because you've tested it.
Yeah. Oh, that's really, really awesome. Now, are there any other things that you're working on, allowed to share, obviously, that you're excited about, like that people can expect in Kubernetes land?
I think a couple of things that we are thinking about, like going forward. Let me. I have to think about what I'm allowed to talk about and what I'm not, because it's a fine line there, and I don't want to give away too much. But we definitely are working. Things that we are working on is like maybe honestly, is to try and simplify the installation experience. At this point of time, a lot of people they run into problems while they're installing, and we're thinking hard about a solution that should make like installing Consul, upgrading Consul on Kubernetes a simpler experience. Now, there are a couple of ways that we can kind of approach this problem, and so I think at this point in time, what we're doing is we are evaluating a couple of ideas. But in the near future, we definitely will. Like, I know this sounds like I'm teasing something, but I'm scared of giving too much away.
Yeah, basically you don't know what you can say, but it's like one of the focus areas, at least, right? Exactly. Like you want to improve that, and
we want to improve.
I'm excited about that because the current experience is already pretty good.
It's good, and we use Ham. I know that a lot of people sometimes, like, when things work, they just work really great, and it's snappy, and it's really good. But there are issues that people run into, especially with slightly more complicated installations where it could get trickier. And we're trying to simplify even those more complicated like deployment patterns that people want to, like people would want on their clusters. So like our primary focus going forward, like one of the key things you're going to focus on is like the day zero experience. And that also extends into like day one experience and day two experience of Consul. But try and get like build some tooling that is going to vastly improve our day zero experience.
Nice.
So I know that's like a big tease.
No, but
I'm
excited about it because anything that like Consul is one of those things for me where Consul is at its best when I don't know it's there, but it's doing amazing things beneath the surface, right? Just like with the transparent proxy, right? Like that to me is the most magical thing. And like if the installation is simpler and if maintaining it is simpler, that just adds to that. So that's a huge plus in my book.
Yeah, I mean, we should ask the chat what features would they like to see in upcoming versions of Consul. It might be a good way for us to like solicit broader feedback about what the community would like.
Yeah, well, you just asked them. Like, please, everybody in chat, like let us know. Like, what are you excited about? And then Ashwin will discuss it. We got a question about the redeployment order. Now, Mohammed is asking if it should be application first and then proxy next. So I'm guessing so let me first clarify. When you say proxy, do you mean the sidecar or do you mean let's say like a web proxy in front of it that is talking to the API?
Yeah, I'm sorry. Yeah, I should have been more
or
clear.
App.
When I say all this, like throughout this presentation, if I ever said proxy, I mean the Envoy proxy that runs as a sidecar to your workload. Yeah. And so when you deploy
there is no
your
extra proxy, right? It is just those sidecars that talk directly.
Oh, it is just those sidecars. That's it. It's like what you always expect from the service mesh, which is gives you a sidecar proxy, which routes all of the networking. You still have that. Yep. And this is what, so whenever I've said proxy so far, I always meant the sidecar proxy, which gives you all of the MTLS networking goodness.
Yeah. And so his question was about the sidecar. Now, the nice thing there is when you have the inject annotation, it'll handle it for you. So connect on Kubernetes will actually inject it for you again and reconfigure it, and you don't have to worry about that.
That's right. So absolutely. So at this point in time, like in terms of order, you don't user does not have to worry about the sidecar because the sidecar gets injected by the webhook. When the webhook, it's like, oh, there's a new workload. What do I do with this new workload? Well, add these init containers to set things up and also add this sidecar container so that it runs alongside the workload. And that's it, you're done.
Yeah, and the sidecar gets injected before the main application is started, so it'll already be there. And then it has health checks on all of the endpoints to make sure no traffic ends up there or any listeners are really there until it is healthy.
Exactly. So it waits for things to get healthy, and it relies on both health checks from like your Kubernetes health checks itself and some internal health checks configured by Consul. And when all of those are green, it lets Consul know that, hey, I am up and ready, and feel free to send traffic my way whenever there is any.
Yep. Yeah. Speaking of health checks, I don't know if I remember correctly, but wasn't that also one of the improvements a while back?
Oh yeah, it's been. I feel like I said, this last 6 months has felt like 30 years.
Yeah.
But
I know how you feel.
So 30 years ago, we built health checks. No, yes, that's right. So we do have support for Kubernetes health checks as well. So I think previously we relied on Consul health checks, but now the health checks from your pod. And so if your pod is not ready, it ensures that Consul is aware that the pod is not ready. It looks at the health checks of Kubernetes itself and as an additional check on whether to route traffic to a container or not. And so if your pod transitions from a ready to not ready status, immediately Consul is made aware of it and it ensures that no traffic is sent to a pod that is unready.
Yeah, which is also one of those nice things that if you're migrating, like you don't have to worry about it initially, right? You can already leverage what you have.
Yeah, and while your app is coming up, you can leverage that feature to ensure that it's like, it ensures that things work how you'd expect them to, I guess, right?
Yeah.
Which is traffic not getting sent to something that shouldn't be receiving traffic.
Yeah, 100%. Now, what is the future for transparent proxy? Like, can we expect more things with the transparent proxy?
That's a great question. I think at this point of time, things that we're working on is the multi-cluster story for proxy. So at this point of time, like everything's is within a single Kubernetes cluster. It just works well and good. But we're trying to figure out a good journey for in a multi-cluster situation. So you have, say, a Consul federation.
Yeah.
You have apps running in different Consul clusters. We're trying to envision what transparent proxy communication looks like across data centers.
Okay, so would that be with Mesh Gateway Federation or the traditional WAN Federation?
You're right. This is using the Mesh Gateway Federation. It would communicate over the Mesh Gateway, but we're trying to what's the best way that we can configure apps running in different data centers to transparently talk to each other. Now, it raises an interesting question, which is what does transparent even mean in a multi-cluster situation?
Yeah.
And is it a failover? Is it actually routing to something that is explicitly in a separate data center? So it's an interesting question because it's hard to always determine what expected behavior is. Because once you know what's expected, it's easier to capture that. But to think in terms of what if I had to configure it in such a way that I needed my app to know its upstream is in the data, should it know it's in a different data center? Should it not? Because what would a user expect? So trying to think through some of those user journeys gets interesting. But that is definitely what's in our pipelines. We're trying to have really good, first-class multi-cluster support for transparent proxy. That's what's coming up on the transparent proxy side.
Nice.
What should be interesting is we're also updating some of our config entries to support transparent proxy. So with proxy defaults, with your service defaults. So at this point of time, they don't work. The new transparent proxy configs are designed for your VM workloads, not so much for your Kubernetes workloads, because on Kubernetes, you're using annotations for configuration. So we don't expect users to use config entries for it.
Yeah.
But we also are updating service defaults with upstream configs. Now, this is a way for users to have some more fine-grained control. So that is what you can do with intentions. But if you want a little more fine-grained control about who your upstreams are, or if you want to configure your upstreams in terms of retries and timeouts, service defaults will now, in the next release, have a section dedicated to configuring a bunch of upstreams and a default upstream for a service. So that should give users a lot of control, further control over upstream management.
Yeah. Yeah.
But this is a day one, day two kind.
Features.
Exactly.
Nice.
This is a very day one, day two operation, but it definitely is something that is very powerful. And I think if you have a lot of workloads and you want to migrate towards transparent proxy, here are more dials that you get to have more fine-grained control about how your services talk to each other.
Nice. We have another question from Brian. Is there a good way to use the proxies with something that manages the pods that may scale the pods to 0, but still ensure that the Consul service is available?
Interesting. Auto-scaling for your workloads. I don't think we have auto-scaling for workloads at this point of time.
Well, you could use the one built into Kubernetes, right?
Kubernetes.
How would it work? You can use basically when it would scale to 0. I think that's part of the underlying.
That's an interest. Yeah, can you scale something down to? It's almost like it's your serverless problem, right? Where Ideally, you'd want nothing listening, and then as soon as there's traffic, you can spin something up and get it to listen to it. I don't know if there is an solution right now that would allow you to have 0 instances. I think because if you have 0 instances, you won't have a proxy sidecar running.
Maybe
and that
with
would make it
Knative.
tricky. Potentially with Knative. Like Knative should allow that.
Because it has that mechanism at least, right? Like, oh, you're trying to hit an endpoint, scale up.
It doesn't exist, scale up. And I don't know if we've played around with Knative and Consul together, where you have Knative
so I'm
managing
quite
your
curious
workloads,
now.
but it's in the service mesh. That's an interesting question. Like that's a very, very good question, Ben. I think the answer to it currently is using just Consul at the moment. I think the answer is no. But I think we can tinker around. Like we should probably tinker around on our side with Knative to see if that is possible. Because yes, like you mentioned, Knative does allow auto scaling and scale to 0. How that plays with the idea that that isn't a proxy is I want to tease out a little more and play around with myself to get a sense for. But I don't know the answer to that question. I think the answer is no. I'd be so happy if I'm wrong though.
It would be amazing if it did work.
I'd be pleased.
We'll need to test that out because it's quite an interesting thing. Because I haven't played around with Knative and Consul Connect yet to see how that interaction works. Another question I think about basically the reliability and upstream configuration you were talking about. Does that mean that we will be able to load balance / failover upstreams?
Yes, I think like in terms of failovers, I think we've had in the past the ability to failover as well. I think service splitter, service resolvers.
Service resolvers could do
could do failover.
Yeah, you could specify a failover.
Yeah, and I think they could do load balancing as well. So I don't think you ever service splitters allowed you to do load balancing.
Yes, yeah, you could say percentage to there.
Yeah.
Well, and obviously by default it'll round robin as well, right? But
exactly. So I think those are still the mechanisms that you'd use for failovers as well as load balancing. I need to take a peek. I don't remember all of the details. I
think the new things would be more around reliability things and like retries and things like that, right?
Exactly, like
recovering from things going wrong instead of failover obviously is the main one of that, but
failover kind of, but this is more to do with, hey, if this is my upstream, how long should I wait for it to be available if it says it's not?
Yeah, how many times should I retry?
Exactly. What's the duration that I should keep this connection open? Things like that.
Yeah.
I hope that answered the question.
Yeah. So the auto scaling that Brian was talking about is something similar to Knative, OpenFast, right? So, and the gateway can handle scaling, but each pod has the proxies injected. I think that would probably work the same because it should still inject the proxy. Exactly. I'm just curious how the routing and everything would go from there, but I think that's an interesting experiment for us to try out and see what happens.
I'm fairly certain that say you have a deployment and you bump the number of replicas you want on the deployment from say 1 to 3, those other 2 new pods that get generated do get injected as well.
Yeah.
So I can see an autoscaler just working. Like if you got your annotations configured correctly for things to get injected, I can see how something going from 0 like up to 1 will immediately get injected. It's going to be interesting only because it takes a couple of seconds for like your init containers to run and for your workload to get up and running and your sidecar to kind of just get registered and have all the upstreams configured. So I wonder if like what kind of response time you'd get.
I think it should be okay because Knative has that like warm up in it, right? Where the initial request would be a bit slower and then it ramps up.
It ramps. Yeah,
Yeah.
it should be fine. Exactly. I think you will like starting from cold, you will always have these issues of warming up. And I don't see it being any different in this case. But yeah, I don't see why that wouldn't work if you had a controller that managed the auto scaling for you.
Yeah. I think that's something we'll have to try
Yeah.
off stream.
Should be a fun experiment.
Yeah. You can stop sharing your screen, by the way, then I can put
Oh.
you bigger on
There
the
we
screen.
go.
I mean, that's what everybody wants.
That's
There we
the
go.
money
Boom.
money thing.
Yeah, well, in case anybody was wondering watching this is actually Ashwin's background. This is not a Zoom background.
Oh yeah, this is not a Zoom background. This is real.
Oh well, yeah. When you move and you
why
see all the
would
stuff
you,
on the table,
why would one have a Zoom background that has trash on it?
Yeah. All right.
Oh.
Yeah. If anybody has any last minute questions, I think we'll take a final question, and then I think we can wrap up.
Yeah.
Is there anything good, like you now have the stage to like reach out to the community and maybe ask for input or whatever?
Sure. I mean, at this point of time, we have a survey up on GitHub for on Consul Ham. If you haven't had a chance to take the survey yet, we'd be very happy to know like how you use Consul, where do you deploy it. If you have any issues running Consul, like feel free to open an issue. Like we're more than happy to receive feedback from community. And if you haven't tried Consul, what are you doing? Use Consul. It'll be fun.
I'm going to link them to the survey.
That'd be great. Thank you so much, Erik.
I think that should be it. So yeah, I think getting input from users is always the best thing.
Yeah, like we're trying to build a service mesh for the community, and no better way of getting feedback than from the community. And we'd love to hear what, like, if there's a feature that you really, really like, give us that feedback as well. It helps to know when we do something right, and it helps to know where we could be doing something better. So happy to hear things one way or the other. Yeah.
I couldn't have said.
What would you like? What do you have any feedback for Consul, Erik? What would you like to see in the next release of Consul?
I think like what I would be really excited about is getting the transparent proxy experience.
Yeah.
Like between Kubernetes and VMs, for instance.
Right.
Where I could just say console or whatever api.service.console, and then transparently goes to somewhere.
It should. I think so. With using some of the config entries that I talked about, you should be able to set up your workloads running on VMs so that you can transparently. So if all of them are within the same data center, so you have workloads running on VMs and workloads running on Kubernetes all in the same data center, you should be allowed to transparently, like transparent proxy will work on workloads and VMs as well. I should have mentioned that, but yes.
Okay.
You can have workloads and VMs.
Talk to like from a VM, refer to a service on Kubernetes.
Like whatever the service name, so how we referred to the API as HTTP API. Similarly, like that would be the upstream. But I would use
the Consul DNS name for that service, or
you'd use the kubedns name because within Consul it gets registered with the kubedns name. So you could like Consul would know how to route your traffic, even if it's from a VM, to the correct service.
All right. And so I'm thinking now, right? Like if I want to refer to a very specific service, I would do service name.namespace.cluster.local, right? Inside of Kubernetes.
Yes.
Is that how it gets registered?
I think it gets registered more just the service name. I don't think all of the alternative names also get registered. It's just the subject name.
Okay.
Not your alternative.
So I could just say names. API then.
You could just say API.
Okay. And then
so that should work.
I would just have to point my DNS of the VM to, let's say, like a DNS mask or whatever that then forwards it to Consul DNS.
I'm guessing if your workload on the VM is also within the console service mesh.
Oh yeah, if it, I wasn't even thinking. I was thinking of plain services, but obviously it's already connect enabled, so it's
exactly.
much simpler.
If it's connected enabled, it should just know that this upstream exists because it should get registered with it.
Yeah. All right. That's exciting. I'm gonna play around with that.
That should be fun. Yeah, would be more than happy to hear your feedback on it. We've been working it's been a lot of months where we worked really hard, so we're excited for people to try it, and we'd love to hear feedback on it.
Yeah. So I have. Well, I'm gonna do like 1.5 questions, right?
All right, let's do a question and a half.
So the first question was, how would Consul fit into the data mesh context? I'm not quite sure what Mohammed means with the data mesh context, but maybe it makes sense to you. And how is auth-n done?
How is authentication done? So authentication at this point in time is like within the app or for services itself, you have ACLs, and you can use ACLs where each single, like every service that you deploy is given ACLs, and it uses that when it makes requests in the header of the request, it kind of puts what its token is, and that is used for both authentication and authorization. I guess the question I'd ask is this when someone says authentication, is it authentication of a service, or is it authentication for the user that's using Consul, in which case you probably have
it would be for a service, right? Like, so it would basically be a Kubernetes service account that gets
exactly. So we have precisely when somebody creates a service, the service account gets bound with a token, and every request that the service then makes has the token in it, which can be used, which then the receiving service can look it up through Consul to be like, hey, this is the token that I received. Is this service who the service says it is? And additionally, now that I know this service is who the service says it is, can this service perform this operation? So both authentication and authorization happens via the ACL token, but that is how we currently perform authentication. In terms of the data mesh question, I don't think I completely understood the question.
I'm wondering if with data mesh, he means the data plane of the service mesh, and that would just be the same as any other service mesh, just a bunch of Envoy proxies.
Just a bunch of Envoy proxies chattering with each other over MTLS.
Yeah. I guess, how does the transparent work when replatforming, so brownfield applications? So I think that's basically the VM to Kubernetes that we talked about before, where I've done experiments before where I've basically service meshed a COBOL application with Connect, and that worked. There is a nice way to go from legacy applications to adding them to the service mesh to do the service discovery, and then moving them to a container or whatever.
Precisely. Like you'd start with moving it just to Consul service discovery, and then containerize it, and then kind of put it into your mesh. So I guess, like you mentioned, those would be the steps one would take for more brownfield applications. Yeah. All
right. So, well, we have Rosemary and David. Thank you, both helping out in chat, answering questions as well. If there's any more questions, please reach out to us. Let us know. Please fill out that survey, because that'll greatly help, like choosing what we do next, etc. And
it gives feedback is very valuable. Love me some feedback. Please feel free to go and fill that.
Yeah. So with that, thank you, Ashwin, for doing this with me. It was awesome.
It was a pleasure, Erik. Thank you so much.
Very happy driving your demos from now on. And thank you, everyone, for tuning in. Hope you have a nice day. It's Friday. Have a nice weekend.
Have a great weekend, everybody.
Yeah. Thank you all, and see you all later. Bye.
Bye.